Every real innovation is responsible for breaking down the wall of skepticism. In recent years, use of composite materials, born of advanced sectors such as aviation and aerospace, has spread rapidly. Today, we can find them in more common consumer products. Market and tendency towards continuous performance improvement have been the catalyst for this spread. Concrete distribution machineries were born and evolved with steel. This material has improved over time until the achievement of resistance characteristics, able to guarantee very high mechanical properties. There are two main issues that limit the efficiency of steel structures. Unlike resistance that can reach very high values depending on the type of steel, stiffness is an immutable physical factor that cannot be increased. With growing demand on performance, this can become an important limit. The second issue concerns the main process of joining, welding. Welds are always the most critical areas because they inevitably introduce defects locally. Structures made of composite materials have completely different properties. The base material is composed of fibers that can achieve high mechanical characteristics which are impregnated with resin. The known molding techniques allow us to avoid critical joints which may affect resistance in that area, and the product is realized in a single piece. Nowadays, these techniques guarantee a high degree of repeatability and an excellent level of quality throughout the process. It is very common that construction equipment is subjected to abnormal stress, shock and misuse that go beyond the nominal loads. These can produce defects in the component. In steel, local damage comes in the form of cracks that propagate throughout the entire thickness. It is an inexorable process which over time leads to component collapse. This does not happen in composite structures in which damage is evidenced as local delamination and therefore remains confined only to the concerned layers without reaching the collapse of the structure. This difference is largely due to the fact that components are produced using a number of overlaid sheets, commonly known as layers. Composite materials are designed and constructed according to the specific application, as opposed to steel structures, which mostly use constant thickness steel sheets. Composite materials allow us to use different thicknesses when necessary, making component design and construction more efficient. CIFA not only designs the component, but also defines materials and construction processes. Another important quality of products built with these materials is that they can be repaired, recovering their characteristics of initial resistance. The compromise between costs and benefits is a fundamental balance. Price is one of the most critical aspects that would make technological solutions like composite materials less attractive. It wouldn't make sense today to design an entire boom in composite material. It is more important to define which are the components that can match performance with an acceptable cost increase. In our machines, there are components that are subject to severe levels of stress. The use of materials that ensure high structural performances allows us to maximize the characteristics of the whole machine. The American writer Kurt Vonnegut claimed that a flaw in human character is that everybody wants to build and nobody wants to do maintenance. Thanks to the use of carbon fiber, we can say that a repaired component resumes all its previous characteristics, making it the equivalent of a new part. Machines, in this case truck-mounted pumps, are subject to periodic inspections according to safety regulations. In case of damage, a report should be sent to the local dealer or to the headquarters. For superficial damage, it's possible to make the repair on site, using CIFA trained personnel. For more complex repairs, CIFA has a dedicated area at the European Testing Centre, the research office inside the headquarters. Even for massive damage that involves more than half of the boom section, it may be worth proceeding with a repair. In many cases, the customer himself decides to repair or replace the component, a choice which may depend on insurance coverage. Each operation is performed by qualified personnel that CIFA trains in its academy service.
In
CIFA, all boom sections are calculated according to specific nominal loads. Carbon fiber permits us to obtain longer booms at the same weight. Requests related to machine weight today are restrictive. To reduce this factor allows us to respect the weight limits governing road regulations, at the same time increasing the payload. Carbon fiber has a double advantage. CIFA is able to produce, for the same class of booms, lighter machines, and for the same weight, machines with longer booms. From the customer's point of view, it means going onto the building site with a higher class machine. The choice of composite materials has projected CIFA to the top level of technological innovation in this industry. In the last 5 years, CIFA has constantly optimized the process of experimenting new solutions, making it qualitatively more reliable and economical. Today, components in carbon fiber are much more than a technological advantage. For CIFA, innovation and research are now real strengths for the company that is projected towards the future, mindful of playing a positive role in the development of the sector.